In this video, you are going to learn about fully remote MCP server. This video is going to be interesting one, and in this video, I'll be going to cover how to initialize your project, and we'll look into one example in FastMCP 2.0 and Streamable-http stateless. We'll have a Docker file and we'll run that in locally. We'll push the Docker file in Docker Hub. At the end, we will be deploying our code to the cloud and accessing those remote MCP server in the local. This is going to be a long video. In this video, you'll understand end to end how to make a remote MCP server. If you are the one who are started building the MCP server, this video is going to be really helpful for you. For testing throughout this video, we'll be using Postman request just to get the inner side of how the LLM is being called, and we'll be using VSCode for the integration of the client. Important thing, like I've researched this a lot, and most of the things, if you wanted to even find on ChatGPT, you won't be able to find the information. This is a structured overview of the remote MCP server. So if you follow this along, you'll be able to create your own MCP server and deploy it to the cloud. So one thing to note, like this is without authentication, and we are not using anything like JWT token also for the session management. But if you wanted to have the basic flow of the MCP remote MCP server, you'll get to know from starting to end. So few things before we go into the code, which we should understand. The MCP provides few transport protocol. One of them is the Studio one, another is the Streamable-http, and another is SSE. I'll give you a little overview about these transport protocol. One is STDIO, is basically used for the local tools development and best when you wanted to run your both server as well as client on the same machine. So this is not that much scalable. Making the changes in the server side will really difficult, and this is not the one which anyone will encourage if you wanted to provide a real MCP server to someone. SSC is a deprecated one. So we should use the Streamable HTTP, which is a web-based deployment. So you have your server hosted on the cloud, and some client wanted to use it, they can use with the URL. So because we wanted to create some microservices also and use in serverless, so we would not want to have our server to be stateful. When we say stateful, it means we don't want to attach with the long running sessions. Instead, we want it to be stateless, so that we can scale our services and deploy our services as a microservices, and even use this serverless technologies which we have as of now. So this is the little theory part. Let's get into the detail of creating the remote MCP server. So for this, I'll be using FastMCP 2.0. So let's see the documentation. This is the documentation of FastMCP 2.0. In this, they have given a basic introduction, and they have created a basic tool for add, and for the installation they have given the instruction like you can add add FastMCP, you can even use pip. So this is the basic instruction. So one thing to notice here, like FastMCP 1.0 and 2.0 has few changes. This streamable HTTP is available in FastMCP 2.0. It is not in FastMCP 1.0. So for importing the 1.0, we were using something like this mcp.server.fastmcp, and then from that we are importing the FastMCP. But for 2.0, you can right away start from the FastMCP and import. So for this, I'll be using this documentation, and the example which I'll be using is model context protocol.io, and the same example which we will be I have shown already in the earlier video. This example is about forecasting the weather and getting the alerts on the weather. So I'll be using the same example. So my thought is like it's not about the functionality, it's more about how to deploy your remote MCP server. This particular server will have two tools. One is get alert, another is get forecast. Internally, this will be calling another API, weather API, that will give us that forecast as well as alert. So I'll be using this tool. So as you can see, this particular server was built on FastMCP 1.0, but we need to use the FastMCP 2.0. So to save the time, I have done the basic setup with the after following these steps which we have in installation, and these steps like copy pasting this particular example right over here. We will be using the UV as the package manager here. I have created weather.py. In this, I have initialized the FastMCP server and used the FastMCP 2.0. We have two tools here. One is to get an alert, another is to get forecast. We have used the transport layer as the stdio. So if you wanted to run this particular MCP server, we have to run like uv run, and we can provide our file name. If we will run this, this should start our MCP server. So MCP server has been started with the transport layer stdio. But as our agenda is to create the remote MCP server, we'll change this transport to Streamable-http. So if we look into this particular method, this is in FastMCP 2.0 run method. It takes one of the parameter as the transport, and if we'll look into the implementation of this, if we'll try to go inside the implementation of this, we can see it has the three type of transport: stdio, ssc, and Streamable-http. So we have to use this Streamable-http. We can change this to Streamable-http and save our code. Now if we'll run this particular server, this is started on the on our local host at the port 8000. So this endpoint is available now. This particular endpoint is from where we can access our MCP server as of now. So we can access this via VSCode. In the VSCode, we have to go inside it and we have to click on add more tool, add MCP server. Here also we can see two options. One is by stdio, another is Streamable-http. So we have to select this, and here we have to put the URL which we have for our MCP server, and this is the MCP server. So we can put the name the HTTP MCP weather server. So this is the server which we have. So this will create one entry here. As I was testing it before also, I was having this. I'll remove this setting so that we will be having only one setting running. So this MCP server which we have, we'll restart it and we'll see, yeah, this server is connected and it has discovered the two tools. Now I'll start another session of our VS Code and I'll ask this particular MCP server about what is the weather alert in New York City. So here MCP client will understand that it has to call the tool. It is actually looking into one of the server, which is this, which might be the old server. I think we are not running this. Let's see. Not sure why it is picking that. Let me try to remove the all the earlier servers. Oh, this server is there, right? So now our MCP server is connected to VS Code. I can ask what is the weather alert in Seattle. If I'll ask this, MCP client will get the information of Seattle and it will send the request to our MCP server, and it will tell that there is no active alerts. So it in backend, if you'll see this, and the output is this particular tool we are calling with the client, but we wanted to get little one step deeper because at the end we are doing HTTP call. We can see this with the postman call also. In the postman we can create a request, like this is our endpoint and we wanted to do the tool call, and we wanted to provide the name. So it has the one argument. We have our tool something like this. Here we wanted to call this get alert method, and the arguments we have to provide the name. We have to provide the name of the state. We can take this argument which client is providing. With this, if we will request our MCP server, HTTP MCP server, it will say that session ID is missing. What does this mean? This means this is a stateful server which we are running. We have to provide the session ID in each call, and that particular architecture is not scalable. Both stateful and stateless has their pro and cons, but in this video we wanted to go ahead with the stateless one because that will be useful for scaling your infrastructure, for deploying on microservices. So let's see how to make our server as a stateless one. So for making the server stateless, we already have a server initialization in this FastMCP 2.0. If we look into, we have one of the argument which is stateless HTTP. So we have to pass this argument here. We have to make stateless HTTP as true. That means we are making our server stateless. If after doing that, we have to restart our server. So now our server has restarted and it has started on the same URL at 88,000 port and /MCP. So with this, now if we will do the request, still it is showing this. There is something wrong with that. I think I haven't saved the project. Now after saving it, let's try this. So now our server has started on the same port and same URL. Now try with the Postman. So now you can see, now we don't need a session ID. That means our server has become stateless and it is providing us the response that there is no active alert as of now in the state, and we are able to make our server stateless. So till this point of time, we have created a project. We have made it streamable HTTP and we have made it serverless. But this whole server as of now is still on our local. We wanted to push it to the cloud. For pushing it to the cloud, we wanted to Dockerize our project and we wanted to run that particular Docker image in the cloud. So in our case, we'll be using Render to run our remote server. So if this looks exciting to you, keep watching this video till the end. You will be able to see how to deploy this on the Render. Now we wanted to push this. Now we wanted to push this server to cloud. For this, we wanted to create a Docker file. I'll ask the Copilot to create a Docker file for this. So I have asked the GitHub Copilot to create a Docker file. So GitHub Copilot can easily do this part. So it has created a Docker file based on the Python 3.1.2 Slim, and it has created the Docker file. So this is our Docker file. We can build the Docker image. So let's start with building the Docker image. Create one more terminal here. So it's inside the weather folder. Here I'll build the Docker image. So for this, you need to install the Docker in your local. If Docker installed, then only the Docker image will be created. So with the Docker image, now I am with the Docker file. Now I am creating the Docker image. So this Docker image will be pushed to Docker Hub, and from there, that link I'll be using in Render to create the project. So this is how I have created the Docker image in my local. I can run that Docker image in the local first. So it has started running on this, and Docker has exposed the port 8000 to the outside world. So this is being exposed outside on this particular port. So when we run this, we are able to see that our API we are making a call and we can see the output. So this all looks good. Like in the local, we have verified that our image is running fine. Now our next task is push this particular image to Docker Hub. For doing that, you have to go to the Docker Hub, and for this you can just go to Docker Hub and you can log in there. If you haven't created the account, create the account. I'll just log in with my Google account. So what you can do, you can create another repository here, create a new repository. You can name the repository as the remote MCP server. And if you want, you can give short description. Otherwise, let it be. So you have to push your image like this command. So now you have your image up and running in your local. You wanted to push that to Docker Hub. We can again take the help of the Copilot. Help me push the weather MCP server image to this. So these commands are quite normal. You can Google it also, and you can get all the steps to push it. So first we have to build the image. We are building the image. We already had built it, and we are now building with just the repository name. After building it, so after the image has been built, let's tag the image. So image has been tagged. If you want, we can tag the image with the latest tag also. So both the image has been tagged. Now what we can do, try to do is do the login, because I'm already logged in with Docker. I'm using Podman actually. So you can use the login for your Docker, and if login was already there, you need not to do anything. Once that is been done, you can push the code to your Docker Hub. So this code is already been pushed once, like already earlier I have pushed it, but now also I'll try to push it, and I'll push the same latest tag also to our Docker Hub. So once the code is pushed, let's go to the our UI, go to the Docker Hub and try to see, like, can we see the image. So this is the Docker Hub which we have. This is the repository which we have created. So if we'll refresh it, so it is just pushed those to here. So we know this has been pushed here in the Docker Hub. So we have achieved this point of time that our image has been pushed to Docker Hub. Now the last part remaining is to create a web service on Render. Render is having a really nice free tier to start the web service. So for that, just open the Render, go to render.com. You can just click on this. You'll see this screen on render.com. Just click on get started. I have already logged in, but if you are new, just log in. You can even log in with your Google account. It's quite straightforward. Once that, click on add new. You'll be able to see web service option. Just click that. In this, you can see existing image as one of the option. Just take the image which you have already pushed just now and put it here. If everything is fine with the image, it will give you the option to connect. And because we are keeping everything as default apart from the instance type, which we just want for the free as the hobby one, and just deploy the server. So this will show us the logs for the deployment logs. If there is some issues, we can find it here. So it will take some time to start the service. It is showing in progress. So our service has been deployed without any issue. So it's a good indication. Yep. So now our service is live, up and running on this particular endpoint. We can copy this endpoint and try to test with our Postman. In Postman, we were already having this. Just put the latest endpoint and try to run it. It is connected and we can see the message. That means our cloud server is working fine and we are able to connect from our local Postman. We can do the similar integration with VSCode also. For that, we'll go to VSCode, go down, add more tool, MCP server, HTTP, put MCP, name, just add remote and at the end, just for identification, user setting. Yes, now you can see that your server is here. Let's restart it to see the logs. Yes, server is up and running. It can show that there are two tools discovered here. Start a new terminal in the Copilot. Just write what is the forecast for New York City and put enter. So our client will understand what exactly it has to do. It will send a request to my MCP server remote. It will pass this as the input and will do the continue. Once this is continue, it will go down and it will give us the response in readable form. So with this, we are able to deploy our remote server to the cloud. We are able to access those server from our local Postman and even with the MCP client. Hope this video was helpful. So keep learning, keep building. Goodbye.